The next principle in economic equivalence is called the equivalence depends on interest rate. So what that means is when you have a series of cash flows, for example, this future value of, let's say, $1,000 is equal to some present value right now, and it's because of a certain interest rate being perhaps 10%. Now, if this interest rate changes to something like 8%, so it's worth 9,009.09 present worth. Now, these two values are economically equivalent because of this 10%. If this 10% changes to 8%, what happens is these two are no longer equivalent. So this $1,000 is no longer equivalent to this point, which was $909, but instead it's going to be 8% below $1,000. So that's the concept. So it's 925.93. The next principle in economic equivalence is called the equivalence depends on interest rate. So what that means is when you have a series of cash flows, for example, this future value of, let's say, $1,000 is equal to some present value right now, and it's because of a certain interest rate being perhaps 10%. Now, if this interest rate changes, if it changes to something like 8%, so it's worth 9,009.09 present worth. Now, these two values are economically equivalent because of this 10%. If this 10% changes to 8%, what happens is these two are no longer equivalent. So this $1,000 is no longer equivalent to this point, which was $909, but instead it's going to be 8% below $1,000. So that's the concept. So it's 925.93. So you see these two values over here so you see these two values over here, this one and this one, are equivalent at 10%. So if this was 0 and 1, these two are equivalent at 10%, but they're not equivalent at 8%. So that's what the equivalence depends on interest rate principle is. Next one is principle 2, or the next principle is multiple cash flows may need to be converted to single cash flows. This principle is very important because you wanna be able to take a series or a number of cash flows and make them into one. So for example, if you go to the bank, or if you go to buy a car, you have to pay a certain amount back. So let's say you buy like a $2,000 car, or actually let's not put the value yet. So you are asked to pay in one of the payment plans, payment plan 1, you are asked to pay initially $500, and then 10% interest. So over here it'd be like 550, and so on and so forth. And then you are asked to pay another one, another payment plan. This is your alternative number 2. You are asked to pay, let's say, 600, and this one is at 3%, or okay, this one is at 7% interest. So what is 7% of 600? It's 642. So after 5 years, they will ask you to find out, or they will ask you after 5 years. So let's say the payment plan is for 5 years. After 5 years, which option would make you pay the least money for the car? That's the option you would choose in this case. So after 5 years, you would have to convert each of these cash flows, because suppose this pay plan starts off 500 and then becomes 550, and then let's say it's an irregular type of cash flow. So this one is 400, and then this one is 600, and you would have to take all of these cash flows and put it into one period. So for example, you would calculate the future worth at this point. You would take 500 times 10% of over 5 periods, 550, 4 periods, and you do 10% of that. So you can convert each of these cash flows into one single cash flow here. And it doesn't just have to be at this point. It could be at this point, or any point for that matter. Now, you might be thinking, why is this so important? In some questions, we will see that there are certain pattern of cash flows. One of the questions that we'll be doing later on, they will have patterns of cash flows. How would you do this case? You would probably break this up, and you break this up into one cash flow series or one type of equation, right? You would convert this into one cash flow over here like that, and you'd convert this one, this one, and this one, like that. And you could then take this cash flow and this cash flow and convert it into one big cash flow. Just to review, the reason multiple cash flows may need to be converted to single cash flows is because we will see patterns in our cash flow where we would take them in chunks and calculate them into their individual one cash flow, and then we would take those individual cash flows of that pattern and convert those into one. And it could be at this point or this point, and we could take this one and convert this one at any period in our timeline. When I say convert this cash flow, I mean take this single cash flow and you can find its economic equivalent not at just the future or at the end of the period, but at any period if you are given a certain interest rate. If you're given a certain interest rate, you could take the single cash flow and find its economic equivalence at any other period on this timeline. So that's what the third principle is really about. Principle 4 talks about it doesn't really matter what point of view you are in, the cash flow is still economically equivalent. So if you have, let's say, somebody here who is doing some sort of trade or something with so Jack, this is Jack and this is Jackie. My drawing isn't the best, so I'll try my best here. Jackie, Jack, so Jack is lending. He's lending $100 to Jackie and she's borrowing from Jack. What happens is that if the interest rate is the same, then it doesn't matter which point of view you are in. So you could be the lender or the borrower. The value would be, if he's lending $100 to Jackie for a year at 10%, and she has to pay this amount back, these two values would be economically equivalent if the percentage stayed the same between the 2 point of views. So that's the fourth principle, and now we'll do some examples to so that's the fourth principle. And next we are going to talk about the different types of cash flows and talk about interest tables, which will help us reduce our calculations.